Let's begin this chapter with a very simple idea. Sometimes, something is missing. In real life, it could be a lost object, a hidden number, or a missing clue. In mathematics, that missing thing is often called a variable. And here we use x, n, y, or any English alphabet to represent it. Our job is not to guess. Our job is to find it using the right steps. Think of an equation like a balance scale. If both sides are equal, the scale stays level. But if one side has extra weight, the balance tips. So what do? We add or remove the same amount from both sides so the scale stays fair. That is the basic idea behind solving equations. Now let's look at the structure of an equation carefully. The left side is called the LHS. The right side is called the RHS. And the bridge, that is sign of an equal to in the middle, shows that both sides have the same value. If we want to solve the equation, we must find the exact value of the hidden letter that makes both sides match perfectly. Sometimes students try random values again and again. That is called the trial and error method. It can work, but it takes time. You keep testing values until the left side matches the right side. For example, if the answer is 49, you may need many tries before you reach it. So, trial and error is possible, but it is slow. We need a better tool. That better tool is the elimination method. Here the idea is simple. Remove unwanted numbers step by step by doing the same operation on both sides. For example, if we have 2n plus 1 equals 99, first subtract 1 from both sides. Then we get 2n equals 98. After that, divide both sides by 2. Finally, we get n equals 49. This method is neat, clean, and much faster. Now let's move to the transposition method, also called inverse operations. The idea is very friendly. Whatever is happening to x, we do the opposite to both sides. If there is plus 7, we subtract 7. If there is minus 4, we add 4. If there is times 5, we divide by 5. If there is divided by 15, we multiply by 15. This is how we rescue the variable and bring it alone. Here is the real key. Every operation has an opposite partner. Addition and subtraction cancel each other. Multiplication and division cancel each other. And when a number shifts from one side of the equation to the other, its sign changes. So plus becomes minus, minus becomes plus, multiply becomes divided by, and divided by becomes multiply. That's the main secret of transposition. Now we begin spotting patterns. Suppose the number of sticks goes 3, 5, 7, 9 as the position increases. What is happening each time? The count increases by 2, and it's an odd series that is always one more than any multiple of 2. So the rule becomes 2n plus 1. This is the smart way to look at patterns. Do not count everything again and again. First look for the hidden rule. So let's use this in a real situation. Imagine Ranjana builds T-shaped patterns with tiles. Look at the top part of the T. Can you see this? There are tiles going left, right, and vertically downward. Let's say there are k tiles on each of the 3 sides. This gives k plus k plus k equals 3k. But wait, don't miss this. There is one center tile where both parts meet. That tile is counted only once, so we add plus 1. Now, equation becomes 3k plus 1. And the question is, will any step use exactly 100 tiles? So we take our rule and set it equal to 100. we get 3k plus 1 equals 100. Now solve it step by step. First, subtract 1. 3k equals 99. Then, divide by 3. K equals 33. So what does that mean? At step 33, the T-shape will have exactly 100 tiles. This is how patterns in the real world become equations. Now let's look at another story. We have two people, Ramesh and Suresh. Together, they have 60 marbles. So we can write x plus y equals 60. Now the second clue says, Ramesh has 30 more marbles than Suresh. So that becomes x equals y plus 30. Now here's the important idea. Instead of solving both separately, we use one equation inside the other. So we replace x in the first equation. That gives y plus 30 plus y equals 60. 2y plus 30 equals 60. On solving, we get y equals 15. Now put that back into x equals y plus 30. So, x equals 15 plus 30 equals 45. So finally, Suresh has 15 marbles and Ramesh has 45 marbles. This shows when two unknowns appear, one clue can help us find the other. Now let's learn the general method. If we have something like ax plus b equals cx plus d, we collect the variable terms on one side and the constant terms on the other. On collecting the like terms on one side, we get ax minus cx equals d minus b. Taking x common, we get x bracket a minus c bracket close equals d minus b. So finally, we have fast shortcut. X equals d minus b divided by a minus c for equations of the form ax plus b equals cx plus d. This is a powerful trick because it helps solve equations with variables on both sides quickly. This is known as Brahmagupta's formula, which gives an idea that if you align the clues properly, the answer appears directly. Now let's wrap everything up. The checklist is simple. Equations are like balance scales. Use inverse operations to isolate the variable. And remember that algebra is really about finding the hidden value. So now you have the tools, the rules, and the blueprint. All that is left is practice.